Here's problem 1324. A satellite of mass m circles a planet of mass big M and radius r in an orbit at a height 2r above the surface of the planet. What minimum energy is required to change the orbit to one for which the height of the satellite is 3r above the surface of the planet? So we have a satellite circling a planet. That means it's moving, and the energy of a moving satellite, a stable energy, is equal to a negative g mass of the planet, mass of the satellite, over 2 times the radius of the orbit. That is the stable energy of a moving satellite. So in this case, here's our planet, a radius r, and the initial position is actually 2r above the surface of the planet. So the actual position of our initial position is going to be 3r away for this satellite as it's moving around in its orbit like this. So our initial energy is going to be that of a stable satellite, which is going to be a negative gm little m over 2 times the radius of its orbit, which is actually 3r. That's from mass to mass, center of mass to mass. So this is going to be a negative gmm over 6r is our initial energy. We are going to change to a new radius that is actually 3r above the surface of the planet. So we're going to go r, r, and then another r. And hence our total distance from the center of the planet is going to be 4r away in our new orbit for the satellite. So our final energy is that of a stable satellite in orbit, which is going to be negative g m little m over 2 times the radius of our new orbit, which is actually 4r. This is going to be a negative g m m over 8r. So we want to find the minimum energy required. That's the amount of energy we need to add in order to get to this new location. Well, that change in energy will equal our final energy minus our initial energy. That's the energy we need to add. And that will be equal to negative g mm over 8r minus our initial energy, which is a negative g mm over 6r. So this is going to be equal to g m little m over r, factoring that out, and we're going to have a negative 1/8 minus minus or plus 1/6. So this is going to be g m little m over r. Negative 1/8, find a common denominator. Negative 1/8 will be a negative 3/24 plus 4/24 for 1/6. So negative 3 plus 4 is going to be 1 and positive. So this is going to be g m little m over 24r. That is our change in energy that we need to go from the first stable orbit to the second stable orbit. So we need to add that amount of energy, the minimum energy required in order to make that change in orbit. Gmm over 24r.